We were
This
discussing
conference will
things
now be
related to
recorded.
digital keypad. So before that, we first discussed the difference between like a blocking delay and a non-blocking delay. So it is always suggested that you are going for a non-blocking delay because blocking delay might sometime lead to the loss of events because the control is going to get blocked whenever you are making use of a blocking delay. So it is always suggested that whenever you have to try creating a delay, you have to go with the non-blocking delay. So we first saw the difference with the blocking and the non-blocking delay. Then we started with the digital keypads configuration. So first we actually understood things with respect to the tactile switch. So basically we understood how a tactile switch is going to work. So we saw two ways of tactile switch getting connected to the microcontroller, either as a pull-up circuit or as a pull-down circuit. So whenever it is the pull up circuit, whenever you have pressed the switch, you will be able to read a 0, and whenever the switch is open, you will be reading a 1 at the pin of the microcontroller. So similarly, in case of a pull down circuit, so whenever the switch has been open, you have to read a 0, and whenever the switch is closed, you will be able to read a 1. And if we talk about the edges getting identified upon switch being pressed, so if you take a pull up circuit, you are going to identify a falling edge or a low level in case of level. But if you take a pull down circuit, so you are going to identify a rising edge and a high level. So that is what we finished discussing in the previous class. So today we had, I'm sorry. Yes, so today we had to start with the programming part of the digital keypad. So yesterday we saw the circuit on board which has been available for the digital keypad. So the circuit on board, if you observe, is like a pull up circuit. So every switch of the digital keypad is connected as a pull up circuit to a particular pin of the microcontroller. So did anybody notice to which pin of the microcontroller these switches are connected? Did anybody notice that to which pin of the microcontroller these switches are connected? So we are talking about digital keypad. Was it C? C in the sense, are you telling that it was port C? RB0 to RB4. So in fact RB5 because six switches together are forming the digital keypad. So if you still want to know, how will you know how the circuit connection is being made on board? How can you be actually knowing what document should you be referring to know how circuit has been connected? So yes, you have to refer the schematic. So I'm going to first choose the board. So it is PIC Genius PIC 16 877A. And please make sure the clock frequency you're working with is 20 megahertz. So for the PIC 16 877A microcontroller, the clock frequency is 20 megahertz. Okay. So after the clock frequency of 20 megahertz, after selecting the microcontroller, so I'm going to help and click on board. So I have to go with the schematic of this particular board. So let me load the schematic. So here I can find the schematic. Okay. So let me first search for the switches. Where are these six switches available? Okay, and I don't think it is actually available here. Okay. Hmm. Okay, so these are like the switches which are being commonly represented. Okay, so in this case I'm not able to like exactly get the switch itself. Okay, only for the switches because I have multiple switches. I can see matrix keypad, but with respect to the digital keypad, Okay. So it is not available here. So which is why actually we have added it in our slide only directly. But you can see the switches connection here. Okay. So yes, so here you can see the switches connection, but here the order of the pin is different. So it has not started from RB0 to RB5. So it is in the different order in fact. So the order you might get confused. So if you can directly observe here, if possible, you can see one switch being connected to RB0, then RB1, then RB2, then RB3, RB4, RB5. Okay, so there are six switches connected from RB0 to RB5. So there is a switch also connected from at RA5 pin of the microcontroller, but we configure it as an individual switch. The other six switches, we call it as a part of the digital keypad. So you can either find it out here, okay, or if you want, you can actually observe the schematic itself, but the problem is it is not in the proper order. But if you still want it to be properly arranged, we have it arranged properly on our slide. So I can show that. Okay. So here, okay, so you can observe. So we have rearranged it, and you can see one switch is being connected to RB0 pin of the microcontroller, then RB1, RB2, RB3, RB4, and RB5. So the six digital keypad or the six tactile switches are being connected to RB0 to RB5 pin of the microcontroller. Okay. Now we have to start programming these switches. Now before I program all these switches at once, we will program one after the other. First we will program a single switch, then we will be programming all switches together. Now tell me to whichever pin the switches are connected. So that is RB0 to RB7. How should this pin be treated as? What should be the direction of these pins? Whether it's an input or it is an output. Okay. So that is input because see, for this particular switch, the pin RB0, RB1, RB2, RB3, RB4 are all output. Okay. So when you press the switch, you will be able to see a 0 or a 1 at the pin of the microcontroller. So to this switch, the pin is serving as an output pin. But to the microcontroller, the pins are opposite to that of the peripheral, which is nothing but input. So RB0 to RB5 has to be treated as input whenever you have configured the keys of a digital keypad. So RB0 to RB5, so I have to be treating it as input. Okay. Now, let us start writing a simple program. So what I have to be doing in my program is, I have to identify if I have pressed the switch 1, and if the switch 1 is being pressed, I have to toggle the LED. Okay. So as long as I have kept the switch pressed, I have to toggle the LED. So we are going to write the very first program for level detection. Okay. So first program we are going to write it for level detection. Now, when to take the action with respect to the level detection or when to take the action with respect to the edge detection is the question. Okay. I'll give you an example of level detection. Have you used your volume up or volume down buttons? So volume up button or volume down button have you used? Okay. Now please understand how volume up button has been working. Assume you will press the switch. Okay. So your volume up button you will press. Assume you keep it pressed for a longer duration. So maybe approximately around 10 milliseconds or 10 seconds. You are keeping the volume up button pressed for 10 milliseconds or 10 seconds. So what is going to happen if you keep the switch pressed for 10 seconds? What are you going to observe? If the switch is pressed for 10 seconds, yes. So it reaches the maximum. I mean, it constantly keeps increasing. As long as you have kept the switch pressed, it constantly keeps increasing until it reaches the maximum point. Okay. So what happens is, for one time switch being pressed, or as long as you have kept the switch pressed, you have to keep taking the action for multiple times. Okay. As long as the switch is being pressed, you have to take the action for multiple times. So even if you observe here, you see the level detection. So whether it is a pull up circuit or a pull down circuit, if you look at the level detection, understand that you see the level for a longer duration. So as long as you keep identifying this particular level, whether it is the low level or the high level, depending on the circuit you have selected. So as long as you keep using this particular level, so you will be able to take the action. So that is level detection, where you end up taking the action for multiple times. That is as long as you have kept the switch pressed. So I would say here, I will make a note. So take action for multiple times. Take action for multiple times. Okay. So that is level detection. So you have to take the action for multiple times as long as the switch is kept pressed. Now let us start writing a program for this. Okay. So first we have to write the main function. Okay. So the main function's return type is void. The input main function takes is also void. So what is that first thing I have to do being in the main function? What is that first task to be performed in the main function? So I have to call the init config function. So I'm going to call the init config function. Now when the init config function is called, control should move to the function's definition. The return type of the init config function call is void, and it doesn't even take anything as an input. Now tell me, what is that first initialization I have to do? So I am going to take only one switch. So let me first write my problem statement. So I have to toggle LED at RD0 as long as RD0 as long as I have kept switch 1, which is connected at RB0 pressed. Okay. So that is I have to do. So I have to toggle the LED at RD0 as long as I have kept switch 1 connected at RB0 pressed. So what is that first thing I have to do? I have two peripherals to be configured right now. One is LED, the other one is the switch. Okay. So first I will do the initialization of the LED. Okay. First basic initialization of the LED. So LED is being connected to the RD0 pin of your microcontroller. So if LED is used, what should be the direction of the pin? If LED is used, what should be the direction of the pin? It has to be output. So RD0 has to be treated as output. How will you write it as an output? How to make RD0 as output? Yes. So if you just write trisD, then it is going, if you write trisD is equal to 0, so the complete pins of trisD will be returned with zeros. So that is going to set RD0 to RD7 as output. But I want only RD0 to be treated as output. Okay. So in fact, you have to write trisD0 is equal to 0. But actually for time being, because all other LEDs might disturb my output's visibility, so let me put it all LEDs as 0, and let me initially turn off all 8 LEDs for the sake of convenience. So I'm writing port D, okay, is equal to 0x00. So this is to turn off all 8 LEDs, okay, just for the sake of proper visibility of my output. So turn off all 8 LEDs. Okay. Now, so that is init config function. So first I did the initialization of the the LEDs. Now the next thing, I have a switch connected at RB0. So what should be the direction of RB0 if there is a switch connected? What should be the direction? It has to be input. So how are you going to make it as an input? How to make RB0 as an input? I should write 1 to what? To what should I be writing a 1? Yes, it has to be tris B0. So I should write tris B0 with a 1. So RB0 will be treated as input. So this is the initializing function which is init config. Okay. So RB0 should be made as input because I have a switch connected. Now coming back to this init config function. So I will first go with the while of 1. Okay. Now being inside while of 1, first I have to check whether I have the RB0 pin pressed. Okay. So I have to check if I have pressed the switch which is connected to RB0 pin. So how to check that? Okay. So I'm repeating my question. Remember, I want to check if the switch at RB0 is being pressed. Okay. So I'll write it as a statement. Check if switch at RB0 is pressed. So how to check this? What if we want to use port B LED instead of port B in this example? Shreya, that is not possible because to one pin, you can use only one particular peripheral. You can either use an LED or you can use a switch. Now, if you use LED there, you cannot use the switch also because the direction of the pin is different. For one, it has to be output. For the other, it has to be input. Okay. Port B and with 0x00. I don't want to go with the complete port B0 and all. So I directly say if I press the switch, what will be red at the pin of the microcontroller? If I press the switch, mine is a pull-up circuit. So it's a pull-up circuit. If the switch is pressed, what will be red? It's a 0 at the pin which is RB0. So I'll write if RB0 is equal to 0, that means switch is pressed, isn't it? I'm configuring only one pin as of now. So I'm checking if RB0 is falling down to 0. RB0 falls down to 0 only if I have pressed switch 1. So if this condition is true, what should I be doing is I have to toggle the LED. So I'll write LED is equal to not of LED. Sorry. So LED I have not taken. I'll write RD0 is equal to not of RD0. Are you following this? Okay. And I will not be able to see the toggling of LED because this happens on a very swift manner. So after this operation, I will actually add a blocking delay itself. So it is not good to use a blocking delay, but still I'm for this particular example, I'm going with a blocking delay. So unsigned int, let's say I is equal to around 1 lakh. Okay, so 1 lakh cannot be taken. So around 50,000. Okay, I minus minus. Okay, so that is it and we are done. Let me explain how this is working. Okay, so first, initially what happens is I have written the program for the level detection. Means as long as I have kept the switch pressed, I should keep taking the action. So it is level detection. Now please understand why is it level detection. So if you take up the action for multiple times throughout the switch press, we call it as level detection. So to start with, I have set the direction of RD0 as output. Okay. And I have written port D as 0x00. That is to turn off all 8 LEDs. Then this B0 is equal to 1. That is to set RB0 as an input. So that was the initialization. Now assume in your hardware you have not pressed the switch. If you have not pressed the switch in the hardware, what will you be reading at the pin of the microcontroller? If switch is not pressed, what will be read? Yes. So you will be reading a 1. Okay. So you will be reading a 1. So you enter into the while of 1. RB0 is equal to 0 will be condition false. So it won't enter into the if block. So as long as the switch is not pressed, you are not entering into the if block. Now assume you press the switch. The moment you press the switch, signal is falling down to 0, and assume you have kept the switch pressed for 10 seconds. Okay, so you are keeping the switch pressed for 10 seconds. Okay, and assume my if block to get executed completely is taking 1 second. Okay, so assume my if block is taking 1 second for its execution. So what is happening is, okay, so what I am doing here is I am checking RB0 is equal to 0. I am at this point of time. Okay, so I am at this point of time checking RB0 is equal to 0. Condition true or false? So I have pressed the switch. Okay, just now I have pressed the switch. So RB0 equal to 0 is true or false? It has to be true. So this is condition true. So you enter into the if block. RD0 is equal to not of RD0. So RD0 will be initially 0. If I have written port D with 0, that means RD0 to RD7, all of them will initially be 0. So RD0 is also 0. Not of RD0 is 1. So 1 will be assigned to RD0. So first time LED is getting turned on. Okay. So LED is getting turned on. So I will write 1. It is the value of the LED. And I have taken a for loop. Assume this whole thing occupied 1 second of time. And you have kept the switch pressed for 10 seconds. Now again you come back. You still have the switch pressed itself. So you are again coming back. What is the value of RD0 now? After 1 second, if you see, what is the value of RD0? It is still, is it 1? I have still pressed the switch. I haven't released it. As long as I have kept the switch pressed, I should be reading the 0 itself. So even now it is 0. So this time also condition is true. So you are toggling the RD0. RD0 was 1. You made it a 0. So again 1 second consumed. Then again after 2 seconds you come back. RB0 is still pressed. So RB0 equal to 0 is condition true again. So you enter into the if block. You will see the toggling of LED. It was 0. It is made 1. Then again after 1 second you will come back. Okay. So you will check RB0 is equal to 0. It is true again. So it will be made as 0. So like this, if I have kept the switch pressed for 10 seconds, how many times the toggling of LED happens, or how many times this action is taken? If I have pressed the switch for 10 seconds, how many times this statement gets executed? Yes. So the statement is going to get executed for 10 times. That means as long as I have kept the switch pressed, I keep taking the action for multiple times. Do you agree? So as long as I have kept the switch pressed, I keep taking the action for multiple times. Throughout this low level, whatever I have been identifying, throughout this low level, I have been taking the action. So that is nothing but the level detection. Okay. So throughout the switch press, if you take the action, we call it as we are taking the action throughout the level. So that is level detection. And I end up seeing the toggling of LED for more than once because I'm taking the action for multiple times. So level detection means as long as you have kept the switch pressed, you have to keep taking the action. Understood? Okay. So the same project as a template is already available. So let me just execute this. Are we not using DD to remove the bouncing effect? So actually, yes, you have to take the bouncing effect into consideration, but that is only when you are doing the edge detection. So for level detection, anyways, you are taking the action for multiple times. Okay. So for the level detection, generally bouncing effect is not going to pay any concern. So it is not going to make any effect. Okay. Okay. So first of all, let me first show you how to load file. Okay, so I'm going to first show how to load like a previous project which is already available. I'm not typing it. So first and the foremost thing, if you have any project open, so please don't delete or remove the project. You always are supposed to just close the project. If you remove or delete, so that is going to delete the project permanently and you will not be able to retrieve it back. So you have to close the project whichever has been opened first. So I'm going to right click and I am going to do close project. Okay. Now I'm going to open the project. So I have some template codes already available. So I have kept it downloaded already. Like here in this. So under in your Moodle material, so you will already get all the template codes, whatever is available. For every peripheral we are going to discuss, there are template codes already available. Okay, so you can just make use of them whenever you want to execute the codes of what we discussed in the class. So I'm going to load the same project, okay, for the level detection. So let that just get copied. So that program is very similar to what I have written here. Okay. So whatever initialization I have done, whatever logic we have written, the same is available here also. First, I'll go to File and click on Open Project. I'm going to browse the path in which the project is available. So I just copied it into my MD class 23008. So template codes, in that under tactile switches, I have a template code by the name level detection, which I'm opening it. So I'm clicking on level detection and open project. Okay. So now I have one header file in this. So I'm opening that header file. Okay. Then I have one source file written here, which is main.h. Okay. So what happens here is, in case if you can observe, so first in the init config function, port D is returned with 0x00, then tris D is returned with 0. So actually you have to change the order. You first have to do the direction set, then you have to write the value to the port. So I wrote tris D is equal to 0x00. This is making RD0 to RD7 as output. Okay. Next, after this, there is port D return with the value 0x00. Okay. So this is to turn off all 8 LEDs. Okay. This is turn off all 8 LEDs. Then there is one more variable called LED1 taken, which is representing RD0. So that is written in a separate header file called main.h, which is under header files. Okay. So if you see here in the header files, there is LED1, which is representing RD0. There is switch 1, which is representing RB0. So on is representing 1 and off is representing 0. Pressed is representing 0. Then LED1 DDR is tris D0. Switch 1 DDR is tris B0. Okay, so we will see here. LED1 means it is RD0. So it is assigned with off, which is nothing but 0. Then LED1 DDR is tris D0. So this was actually not required because anyways we have written it for all the LEDs. So tris D0 is equal to 0 is been written. Then switch 1 DDR means tris B0. So it is written with the value 1, that is to set RB0 as input. Okay, so RB0 as input. Okay, so that is to set RB0 as input. Then coming to the main function, so switch 1 equal to pressed. Switch 1 means RB0 is equal to pressed means 0. I'm doing LED1 is equal to toggling of LED1, that is RD0 is equal to not of RD0. Okay, then a small delay in order to observe the output. So the same program, whatever I wrote, so it has been more readable because of the macros considered. So let me build this and show you the output. So I'm going here to build the project. Okay, so build is been successful and loading is complete. So we will go here to do the file. I'm going to give load hex. Okay, and this time it is template code, tactile switches, then level detection, distribute, default, production, the hex file. Okay, so you have to observe the RD0. Okay, so you have to observe the RD0 now. Please see. So I have kept the switch pressed. You can see my switch is still in the pressed state. Okay, and you can see the toggling of LED for multiple times. The moment I release the switch, the toggling of LED is going to stop. Is my voice breaking? Okay, fine. Yes, I was saying, so as long as I have kept the switch pressed, the toggling of LED is happening. The moment I release the switch, so the toggling of the LED is going to stop. So as long as I have kept the switch pressed, I'm taking the action for multiple times. Hence, we call this program as level detection. Are you able to follow this? Okay. So that was the program for the level detection. Now I have to write one more program for edge detection. Any doubts in level detection? Okay. So proceeding ahead, the next is edge detection. Now, when to take the action with respect to the edge detection is as long as you keep the switch pressed. Okay, so it doesn't matter for how much seconds you have kept the switch pressed. How many edges are you going to identify throughout the switch being pressed? How many edges are you going to identify? So there will be only one edge identified, means one edge with using which you can take the action. When you press the switch, so you will see only one edge. Yes, you have to take care of the bouncing effect also. But leaving the bouncing effect, ideally, if you press the switch, upon switch being pressed, you should see only one edge. If you release the switch, you will see another edge. Okay. When the switch is being pressed, you will see only one edge. So, you have to take the action for only once. So that is edge detection. An example for edge detection is your power button. Okay, assume the power button of your remote control. So assume your TV is initially in the off state. Okay, your TV is initially in the off state. So you will press the switch. Okay, TV is initially in the off state and you are going to press the switch. Now, when you press the switch, assume switch in the sense the power button, you are pressing it for 10 seconds. So, assume you are keeping the switch pressed for 10 seconds. Okay. Now, what happens? You have kept the switch pressed for 10 seconds. What happens with the TV? Initially, it is in the off state. If you have kept the switch pressed for 10 seconds, what will be the response? How many times the action will be taken? Will TV just gets turned on or it does on, off, on, off, on, off? So what happens? It will get turned on only once, right? So doesn't matter for how much duration you have kept the switch pressed. So you are getting the action taken for only once. Okay. So as long as okay, so as long as switch is pressed, okay, so as long as switch is pressed, action is taken only for once. Okay, that is edge detection. As long as the switch is pressed, action is taken for only once. An example for the key which works according to the edge detection is your power button. Okay, now whatever program I wrote here, okay, so it is for level detection. As long as I have kept the switch, I am taking the action. Just think and answer. I am going to retain the same logic, but I have to see the action taken for only once. So it doesn't matter how long I have kept the switch pressed. I should take this action RD0 is equal to not of RD0 for only once. So how do you think I can do? How to make sure this action is taken for only once? How to make sure that this action, no while loop, that is definitely wrong. So I'm not going to change the while loop. So while of 1 is not for the operation this way. While of 1 is to make sure your embedded system is working for infinite number of times. So it is not getting stopped by itself. So that is the reason why we have taken while of 1. Wait inside if make RB0 is equal to 1. Where? Where should I make RB0 equal, RD0 equal to 1 or RB0? By including break. Okay, if you use break, you will come out of the while loop. Okay, if you include break, you will come out of the while loop. Wait inside if till we get back to the idle state 1. Okay. Okay, so Chaitanya is saying I have to wait inside the if block till I release the switch. Okay, but there is a problem. So that ideal is correct. I can wait inside till I come out till I release the switch. I should keep waiting inside the if block itself. But what if I want to take some other actions? Okay, so what if I want to take some other actions? I cannot get stuck as long as I release. Or don't go into if for the same logic alive. Okay, guys, changing RB0 is not possible. Okay, RD0 or RB0 is not the right thing. Okay, so just a simple thing. How will you make sure a logic is working for only once? Think of your normal C program. Yes. So I can take a flag variable. Okay. So I can take a flag variable. See, I will take a flag variable of type a character and have it return with the value 1. Okay. Now, if RB0 is equal to 0 and flag is equal to 1, only then I will make RD0 not of RD0. So before this, I have to make flag back to 0. Okay. So that I'm not going to make any changes later. So flag is made back to 0. Now see what happens. So assume I have kept the switch pressed for 10 seconds itself. Okay. So I'm going to identify one edge. At this point of time, if you check, RB0 equal to 0 is true. Flag equal to 1 is also true. Okay. So both of them are true. So you enter into the if block. You will make flag back to 0. Then RD0 is equal to not of RD0. You took the action for once. Actually, this for loop is not required now. Again, you come back. RB0 equal to 0 is true. At this point of time, RB0 is still giving you 0 itself. But flag is not 0. So you will not enter into the if block. Again, if you come to this point, RB0 is still 0, but flag is not 0. So like this, as long as you have kept the switch pressed, because flag is not 1, so remember, you will not enter into the if block. So this statement what you have written will be taking action for only once. But there is a small problem. After some point of time, again if I press the switch, should I take the action or not? After some amount of time, if I press the switch again, should I take the action or not? I have to take the action. But flag is permanently made 0. At this point of time, after I have released and pressed the switch again, at this point of time, my RB0 is still giving me 0. I should take the action there. But because flag is 0, I cannot take the action there. So how to make sure that action is taken? For the next time, if I press the switch, I want to take the action. How to do that? At some point of time, I have to make flag to 1. Okay. At some point of time, I have to make flag to 1. When? Okay. Yes, I have to again check if the switch is released. Okay. So else if, how to check the switch is released? What will RB0 be giving you? Yes, it will be giving you 1. Okay. So I'm going to make flag back to 1. So like this, when I press the switch, as long as I have kept the switch, it doesn't matter. I will end up taking the action for only once. So this is edge detection or state detection. So edge detection is also referred as state detection because there is a change in the state of the signal whenever the switch is pressed. So I'll show you the same template. So I mean one more template. I'm closing this and I'm opening a new template. So that is, yes, I'll show you the code after this. Wait. So digital keypad I'm opening, not digital keypad. It is state detection. Okay. So there is no change in the header file. Whatever we previously had, we have the same even now. So if you see main.c, the only difference is here. There is an integer variable called ones returned with the value 1. Okay. And if switch 1 is equal to pressed and ones. So ones equal to 1 or just once. It remains the same. So LED is equal to not of LED once. So switch 1 is equal to released. Once is equal to 1. Okay. So actually, yes, before using this, I have to write a delay in order to take care of the bouncing effect. So I should take a small delay to avoid the bouncing effect. So because we are working with the software, okay, we are not literally working with the tactile switch. So we are working with software tactile switch. So I have ignored that bouncing effect in this situation. That if you are literally working with the original hardware, so before checking this logic, you should take a small delay. Now, because I'm avoiding it, the only reason is, so here to take while of one and all to enter into the while loop and all, it is already taking around 1 to 2 seconds. Okay. So not 1 to 2 seconds, 1 to 2 milliseconds. So I am ignoring the bouncing effect only because I'm making this work in a software. So whatever switch we have designed is on a software and that is not creating any bouncing effect. If you are literally working with the hardware switch, then you have to take care of bouncing effect. So before this, add a small delay for around 30 to 40 milliseconds. Okay. And logic has been remain the same. So switch 1 equal to 0 and once equal to 1. So I'm toggling the LED. Else if when switch 1 is equal to released, so once is made back to 1. So I'll build this and show you the output. Okay. So here is the hex file. So actually see I did not turn on all 8 LEDs of port D. So that is why the remaining 7 LEDs are glowing. Okay. Now see I have kept the switch 1 pressed. So in fact I have still kept it pressed. You can see LED was initially 0. Now it turned out to be 1. That is the only thing. Only once the action is taken. Now I release the switch. Again I press the switch. Okay. So action is taken for only once. So again I press the switch. Action is taken. Again I press the switch. Action is taken. So for how much ever time you press the switch, so action will be taken, not for multiple times throughout the switch being pressed. So that is state detection or edge detection. Is that clear? Okay. So note this down. Take a break of 2 minutes. We will move to the next program. Okay, can we proceed? Guys, are you done? Hmm. Where to download the template? So you have it in the materials itself. So can we advance this project and take the output of switch being pressed or released to be displayed on LED screen as a 0 or a 1? Yes, you can. So as of now, we have not learned how to configure a key. Sorry, how to configure the LCD. So it is not possible right now. But going ahead, we do have a small template for that also. We will be discussing in short. Where to add delay for the bouncing effect. So before reading, okay, so before reading this RB0 is equal to 0, before making any decision, you should take a small delay here, a bouncing effect for the bouncing effect. Okay. All right. So let us proceed next. So the next project we are going to do, I mean the next classwork we are going to do is, how many switches do we have in the digital keypad? How many switches do we have in the digital keypad? Yes, so I have 6 switches. So I want to configure all the 6 switches of digital keypad. So whichever switch is pressed, I have to take the action accordingly. Okay. So assume I have to configure all 6 switches of digital keypad. So I would say configure all 6 switches of digital keypad. Okay. Now, after I have configured all 6 switches of digital keypad, so whenever, okay, I can press any of the switch. Whenever switch 1 is pressed, so I have to toggle LED 1. Okay, so I have to toggle LED 1. So there are 7 switches. Okay, so from RB0 to RB5 and one at RA5. So this RA5, because it has been connected to a separate port, you are going to configure that switch separately. You don't consider it as a part of the digital keypad. So you can configure, you can make use of the switch at RA5 separately. Okay. So the 6 switches, because they are being connected to the port B, so we call it together as digital keypad. So whenever switch 1 is being pressed, I have to toggle LED 1 of port D. So that is my task. Okay. So I have to configure all 6 switches of digital keypad. Whenever switch 1 is pressed, I have to toggle LED 1 of port D. Now for this actually, I'm going to take a journal, okay, because I want to like show 2 different files at once. So I cannot do it in a single page like this. So I'm going to write it here and then copy paste it. Are LEDs and switches on the same port B? Yes, actually there is one set of LED which is available on port B. I cannot use both LED and switches of port B together. So only one peripheral can be used at a time. So I am going to use switches. I don't have an option for switches. I have to always use port B itself. So I'm using LED which is connected to port D. Okay. So if you remember when I was showing you the templates, I told you that we will have a habit of writing different peripherals in different files. So here is the first time we are doing it. I will take 2 files. One is main.c file. The other one is digital keypad.c file. Okay. So digital keypad.c file. Okay. Now coming to the main function, I have to do the programming of the main function. So the main function is void. Then I write main. Then return type is void. Then inside this, I have to call the init config function. So I'm calling init config function. Now what should I write in the init config function is the return type is void. Function's name is init config. Okay. So first I have to do the initialization of the LED. Okay. So I have to do initialization of LED. So first, for my sake of convenience, I will set the direction of all 8 LEDs of port D. Okay. So I will set direction of all 8 LEDs of port D. So I want RD0 to RD7 to be treated as output. So how will I do it? How to make RD0 to RD7 as output? Yes, I have to write tris D with the value 0. Then I have to turn off all 8 LEDs of port D. Okay. So I have to turn off all 8 LEDs of port D. Okay. So to turn off all 8 LEDs of port D, I have to write port D with the value 0x00. So port D is written with 0x00. Now after this, I have to do the initialization of the digital keypad. So because it is a separate independent peripheral, I will go with the separate function return called as init digital keypad. So I'm going with init digital keypad function. So this is to do the initialization of digital keypad. Okay, so initialization of digital keypad. So I'm doing it by a separate function called init digital keypad. So that function's definition, I will write it in the separate .c file, that is digital keypad.c. The function's name is init digital keypad. Okay, so init digital keypad. Okay. Now being in the init digital keypad, how many pins should I be configuring here with respect to digital keypad? To which pins do you think the switches are connected? Only RB0 to RB5. Okay. So tell me how to set RB0 to RB5 as input, because only to that I have got the switches connected. So how to set RB0 to RB5 as input? Tris B is equal to 1. What happens if I write tris B is equal to 1? What is the value of 1 here? So 1 means it is something like 0, 0, 0, 0, 0, 0, 0, 1. If I write 1 to the tris B, which pin are you setting the direction? You are setting RB0 only as input. Okay, you're setting RB0 only as input. So that is wrong. Then I have one more answer saying 0x1f. Okay, so if I write 0x1f, so its binary equivalent is something like 0001 1111. So I agree that RB0 to RB5 is been set as input. Okay, so there is no doubt that RB0 to RB5 has been made as input. Okay, but don't you think I'm forcefully making RB6, RB7? Okay, this is actually only 5 pins. I have to take 6 pins. So let's say 1, 1 and all ones. Okay, so what is happening in this case is it is still wrong. So what you have returned, the binary representation is fine. So what you have written as 1 1 and 1 1 is fine. This is making RB0 to RB5 as input. But are you not making RB6 and RB7 forcefully as output by writing it with a 0? Are you not forcefully making it as output? Yes. So that is again wrong. So you are forcefully making it as output. So you don't know what you initially had, but you are forcefully making it as output. That is not right. So you are supposed to only set the direction of RB0 to RB5 whatever RB6 and RB7 had, I have to retain it as it is. So assume tris B initially had something like, so tris B initially had, assume this is tris B, which initially had something like xx. Okay, so what I want at the end is something like this. One second. So at the end, what I want is this x has to be retained as it is. The rest have to be done as 1, 1, 1, 1. So what will you choose to do? So I have to set the bits of a particular variable. So how do you think I'm supposed to do? Which operation? It is not clear. It is setting the bit. Yes, I have to make use of OR, and OR it with what? So we can use what? So we can use bitwise to set 1 and reset at its, yes. So I should use the bitwise operators. So here I have to OR it with 0, 0, 1, 1, 1, 1, 1, 1. Okay. So its hexadecimal equivalent is 0x3f. Okay. Its hexadecimal equivalent is 0x3f. So what I perform here is, okay, so tris B is equal to tris B or with 0x3f. Are you following this? So this is to set RB0 to RB5 as input. Okay, so I've added the comment also, that is to set RB0 to RB5 as input. Okay, next. So that is the initialization of the digital keypad and the initialization of the program we are doing. Now let us get back to the main function. Okay, so here I have to write the main function. So I will go with while of 1. Okay, and being inside while of 1, you have to perform some operation. So there are multiple keys which I have got in my digital keypad. I have to check if there is switch 1 being pressed. Okay. So in order to read the key, I will take an unsigned character variable called key. So I'm going to read the key from the user. So how to read the key is, I will write a separate function called read digital keypad. So this function is going to tell me which switch is being pressed. So I'm calling read digital keypad function. Now let me write the definition here. So the return type is unsigned character. The function's name is read digital keypad. Okay. And as of now, nothing as an input. Okay. Now, let me make you understand how this is working. So this is my port B. Okay. So it's port B where the switches are connected. So in that port B, I have 8 pins starting from RB7 being the most significant bit, then RB6, then RB5, RB4, RB3, RB2, RB1 and RB0. Okay, so these are the switches of the digital keypad which has been connected from RB7 to RB0. Okay, so like this. So do I have any switch connected from RB7 to RB6? Do I have any switch connected from RB7 to RB6? No, I don't have any switch. I should only consider RB0 to RB5. Okay, I should only consider RB0 to RB5. I have to get rid of this. Okay, so what I want to do is, I want to focus on only these. So RB6 and RB7, in my case, I want to consider it as 0. This has to be 0. So this I want it as it is. Whatever RB5 is having, or RB4, or RB3, or RB2, RB1, RB0. So whatever it has, I want to get them as it is. Only RB7 and RB6 should be made 0. So what do you think I have to perform here? Okay, so I have to perform AND with 0x3f. Okay, so 0x3f is 0, 0, 1, 1, 1, 1, 1, 1. Okay, so when I perform AND with 0x3f, I will end up getting the data from RB0 to RB5 only. Now see, there is one switch connected to RB5, which is switch 5. If switch 5 is not pressed, what will I get at RB5 pin? If switch 5 is not pressed, what will I get at RB5 pin? I will get a 1. If switch 4 is not pressed, RB4 gives me 1. If switch 3 is not pressed, RB3 gives me 1. Switch 2 not pressed, RB3 gives me 1. Switch 1 not pressed, RB1 gives me 1. Switch 0 not pressed, RB0 gives me 1. So, when I perform port B, okay, and with 0x3f, okay, and if I end up getting this value, one second, okay, so I'm aligning this. Yes, as I was saying, so if I perform port B and with 0x3f, and I end up getting this value, okay, can I say no switch being pressed? If I end up getting this value in port B, after I do port B and with 0x3f, can I say there is no switch being pressed? Because from RB0 to RB5, if you see, I'm getting 1. So RB6, RB7, I'm least bothered. From RB0 to RB5, I'm getting 1. So none of the switches are being pressed. So this hexadecimal equivalent is 0x3f. When I perform port B and with 0x3f and I end up getting 0x3f, I will say no switches pressed. So I will literally say it as all released. Okay, so I'll say it as all released. Now again, I go with port B. So assume after I perform port B and with 0x3f, this is the value I'm getting. Okay, it is 0x3e. So can you tell me which switch is being pressed here? So which switch? Yes, the switch at RB0. So I would say switch 1. Okay, I'll start from switch 1. So I will say switch 1 is being pressed. So there is a RB0 falling down to 0 means there is a switch at RB0 being pressed. So I will start from switch 1. So it is switch 1. So if I perform port B and with 0x3f and I get 0x3e as an output, I can conclude that I have pressed switch 1. Similarly, can you tell me what is it for switch 2? What is the value I get from port B and with 0x3e for switch 2? So 0, 0, 1, 1, 1, 1. This has to be 0 and this has to be 1. Yes. So it is 0x3d. Okay. So the 0x3d, it is for switch 2. Please help me complete for switch 3, switch 4, switch 5, switch 6. I have 6 switches. So tell me what is the value here? Is it 0x3c? 1, 1, 1, 0, 1, 1. 0x3, how much is that? Is that 3C? For switch 3, guys, yes, it is 3B. That is 1011. So it is 0x3B for switch 3. Next, for switch 4, switch 5, switch 6. 37 0x, okay, 3 0 1 1 1, okay, 7. So it is for switch 4. Okay, then 0x3, sorry, 2F, if I'm not wrong. Okay, for switch 5, and 0x1F for switch 6. Okay, now tell me, if I have to say it is, say if I have to say I have pressed switch 1, what should I read here in the key? If it is switch 1, what will key read in that case? Key equal to 0x, yes, it is 3E. So if key receives 0x3E, I have pressed switch 1. Okay, so read digital keypad should give me 0x3E, telling that I have pressed switch 1. So here I have to toggle the LED. So I'll write RD0 is equal to not of RD0. Now how to do this is, I just say return port D and with 0x3F. Are you getting this? So I will just say return port D and with 0x3F. Everything is the basic C programming. So when I say return port D and with 0x3F, I will get any of these options. So I will get 0x3F, I may get 0x3E, 0x3D, 0x3B, 0x37, 2F, 1F. It can be any of this. So according to what I received, I am supposed to take the action. If key received is 0x3E, so I am going to take the action because that was my question. If I have pressed switch, yes, this is port B, I'm sorry. So if key is switch 1 pressed, so I should receive 0x3E. So RD0 should be made not of RD0. So I want to return this value. How am I getting this value? After I perform port B and with 0x3F. I hope you are following. Now, whatever this return is happening, please understand, for how much ever times I do the function call, it is going to return me the key whichever is being pressed. Okay, so for how much ever times I do the function call, it tells me which key is being pressed. So can you tell me whether this is level detection or edge detection? Can you tell me if it is level detection or edge detection? Yes, is that edge? So for how much ever times I do the function call, it keeps returning. It is level. So it is not returning for only once. For example, assume I have kept the switch pressed for 10 seconds. And assume I will call this function for 10 times. Because I have kept it pressed for 10 seconds, I keep entering this while of 1 and I will keep calling the function for 10 times. Now all the 10 times it returns me the value of port B and with 0x3F. Okay, so this is actually level detection. So if it is state detection, I have to return this for only once. In my read digital keypad function, I have to return this for only once. I will use the same logic. So first I will declare two macros. Okay, so ash define. One macro is level, which represents, let's say, 1. Okay, and ash define one more macro called state, which represents, let's say, 2, or if you want you can take 0, whichever you are comfortable with. Now I have to receive the mode also. So I will receive it into a character variable called mode. Okay. Now if mode, sorry. So if mode is equal to level, I'm going to return this for multiple times. Else, I have to return this for only once. And I am going to do it same as that of my state detection program. So I will take a variable called flag. Okay. So return with the value 1. Okay. First I have to check if I have not pressed any switch. Only then I have to return. Okay. So I have to check if I have not pressed any switch. So I'll go with else. Okay. Inside the else what I do is if I'm checking how to check if it is not pressed. I mean, how to check if any one of the key is pressed. I'll say port B and with, okay, 0x3f. If it is equal to all released or 0x3f, okay, that means I have not pressed any switch. So I'll say not equal to. That means I should have pressed some of the switch. Okay. So, and I also have to make sure flag. Okay. In that case, I will actually have to make flag back to 0. Okay. So flag has to be made 0 and I have to return this value. Okay. And we have to return this value. So if not this, else, for this else if port B and with 0x3f is equal to 0x3f, what should I do? If it is equal to 3f, what should we be doing? That means I have released the switch. If the switch is released, what should I do? Yes, I have to update the flag back to 1. And just for the sake of convenience, because we have a return value, so I'll say return all released outside. So I'll take a macro called all released. Okay. And just for the sake of convenience, we will do it like this. Now observe what happens. Okay. So flag, because I keep calling the read digital keypad function, it is good to take it as a static local variable. If mode is level, how much ever times I do the read digital keypad function, I'm going to return the key value. Else, it must have been state. So first I'm checking port B and with 0x3f is not equal to 0x3f. Just to make sure I have pressed any switch. And okay, I'm checking if it is flag. So flag is equal to 0, return port B and with 0x3f. Else, if port B and with 0x3f is equal to 0x3f, that means I must have released all the switches. So flag is made back to 1. Are you able to understand this? And in this case, you have to remember what is the return value if switch 1 is pressed, what is the return value if switch 2 is pressed and all. So it is actually time consuming. So what you can do is, in your digital keypad.h file, you can define all macros. Switch 1 representing 0x3e, switch 2 representing 0x3f, switch 3 all release representing 0x3f. So that way you can actually give all the values in the macro. Okay. So the same is actually available in the the template also. Why level is taken? Okay. So if you want level detection, you have to pass level detection. If you want state detection, you have to pass state detection. So level detection for keep taking the action as long as the switch is pressed. State detection to make sure action is taken for only once. So how you want the action to be taken, you have to pass here. For read digital keypad, one during function call should be passed. Yes, so level has to be passed. I have taken a macro called level representing the value 1. Why character pointer mode? It is just a integer value I'm passing. So why do we need pointer for mode? Yes, it is not required. Okay, so just for the sake of convenience, I'm taking it. So I'm having it return here also. So this is of main.c file. Okay, so this is main.c and digital keypad also. Digital keypad.c. Okay. Okay, so I have copied it here in the notes also. Now let me show you the same in the templates. So some things are like return as macros just for the sake of easy readability. So let me open that project. I'm opening it with respect to the digital key. So this is the project digital keypad. Okay. So first if you look at the header files, so I have main.h and digital keypad.h. So if you see main.h, there's LED1 representing RD0, LED array 1 representing port D, LED array 1 DDR representing TRIS-D, off representing 0x00. If you see digital keypad.h, level is representing 0, state is representing 1, keypad port means port B, keypad port DDR means TRIS-B, input lines means 0x3F, switch 1 to switch 6, whatever values we wrote, so they are being returned as macros. All released also means 0x3F. Okay. Now coming to the main function. Okay, main.c. So I'll show you the comparison as that of what we wrote. Okay, so to start with the main function, you can see read digital keypad. If key is equal to switch 1 means it is 0x3e. Switch 1 is a macro which is 0x3e. I'm doing LED1 is equal to not of LED1. So I'm doing it state. So if you want, you can, you should use the delay only for level. So I'll keep it as level. Okay. And I want delay only for level. Okay, 1 second. Okay, so something like this, the same thing. Okay, and if you see the digital keypad.c file, so things are very similar. The names are being changed. So TRIS-B is nothing but keypad port DDR. TRIS-B or with 0x3F. 0x3F means input lines. Okay. Then static character variable instead of flag, there we have taken it as ones. Then if mode is equal to level, I'm saying return. Port B means keypad port and with 0x3F means input lines. Else, if keypad port means port B and with input lines is not equal to all released, okay, you can see not equal to all released and once, I'm first making ones to 0. Then I'm saying return port B is keypad port B and with input lines. Else, if keypad port B and with input lines is equal to all released, flag is made back to 1 and at the end return all released. Okay, so here I have missed a block. I have to add that. Are you following this? Now observe the output. So whenever I press switch 1 only, the LED 1 is going to get toggled. Okay, so look at the output here. Whenever I press the switch 1 only, LED 1 will be toggled. So I'm going to File, Load Hex. Then here, under Digital Keypad, Distribute, Default, Production, the hex file. See, I'm pressing switch 1. I have kept it pressed constantly. I haven't released it yet. So you can see the toggling of LED is happening. Okay. The moment I release the switch, it stops. Now for any other switches, it is not performing because I'm taking the action whenever only switch 1 is pressed. Okay. Now one more logic we have written here in main.c. Whichever key is pressed, so that value is being fed to the port D and I will see that on the LED. Okay. So if I press switch 1, port D will take the value 0x3E. If I press switch 2, port D is going to take the value 0x3B. So that way whichever key is pressed, that value is fed to port D and you can see that in the LED. Okay, observe. Okay, so build is complete. Loading is also complete. So I'm doing the file and do the reload last. Now see, I'm pressing the switch 1. Can you see the pattern 0x3E? So see from the bottom. So this is the most significant bit. At the bottom, what you have is the most significant bit. At the top, what you have is the least significant bit. Can you see 0x3E in the LED? Are you able to observe 0x3E on the LED? It is 0. Please read it from the bottom because D7 is the most significant bit. So 00111110. Okay. Now if I press switch 2, observe there is 0x3B, 0011 and 1101. I press switch 3, you can see 0x0011 and 1011. So that way whichever key is pressed, that value you can see it on the LED. Right now it's virtual box and we can press one key at a time. But when on physical board and if we press two keys at a time, then what would be the output at the same time? Would it display the LED glow which is being pressed first? Okay. So because it is virtual, because it is what I say, the physical board. So when you go with the physical board, if you have pressed switch 1 and switch 2 at the same time, both RB0 and RB1 will be falling down to 0. So you will be able to see that LED, okay, the response with respect to LED. But you cannot decide whether it is switch 1 being pressed or switch 2 being pressed because port B will be giving you the value 0011 and 1100. So you cannot make decisions if switch 1 is pressed, you are going to take one action, switch 2 being pressed, you are going to take another action. That decision cannot be made. But if you want to display it on the LED, then you can display it. Making decision is not possible in that case. Okay. I hope you got it. Fine. So that was about the digital keypad, guys. I hope you are able to follow. So this is the program which tells which switch is being pressed. So now later if you want the action to be taken when switch 2 is pressed, this you can make it a switch 2 or switch 3. Any of the 6 switches you can take. Okay. So that is about the digital keypad. So whichever switch is being pressed, you can identify and accordingly you can take the action. And this is the driver code of digital keypad. So that is going to tell which switch is being pressed. And how do you want to take the action? Whether the level or the state, you can decide. Okay. I hope this is being clear. Any doubts? Okay. So this completes the next peripheral, which is nothing but the digital keypad. Hope the classes all been clear. So we are going to start with the next peripheral in tomorrow's class. So you do have lab tomorrow. You will be given with the assignments on LED and digital keypad. You please make sure you are giving it a try. Okay. All right. So please have your attendance marked and then quit the session. That is it for today. We saw 3 programs in total. One was for the edge detection, second one for the state detection, and the third one was to check which switch is being pressed, whether it is the edge or the state, and accordingly we had to take the action. So thanks for attending today's class. We are going to continue tomorrow. Thank you all.